Lauren, what does it look like?
Straight up.
Up?
Oh, sorry, right. Vertically.
Yeah. Horizontally, yes, like this. If we're graphing a line for Alex, what is that going to look like? Vertical from 4, 0. Now, just looking at this graph, does it look like they're going to meet on stage? It looks like it, but do they actually? No. Why not?
Because that's just their path.
Yes, Alex is too fast for Lauren. She reaches the spot too quickly. So here for number 2, we can say we cannot tell that they meet. No, because the graph does not account for what? Speed or time. It does not account for time. So instead, let's try to represent their movement with these tables that are based on time. So we'll have this one be Lauren, and this one be Alex. At time 0, where is Lauren?
6, 0.
And time 1? Time 2? Right. 3, 6, 4, 6, 5, 6, 6, 6, 7, 6. How could we write an equation for x based on time, t? What is x always equal to? X is always equal to the time, t. What is y always equal to? Guess what? You just created what are called parametric equations. They are equations that introduce a third variable called the parameter. And in most cases, parametric equations are based on time. Our third variable is our parameter time. So we have parametric equations that define x and y based on time. Now let's do the same thing for Alex. Where is Alex at time 0? 4, 0 at time 1. 4, 2 at time 3. I'm sorry, time 2. 4, 4 at time 3. 4, 4, 8, 5, 4, 12, 4, 14. How could you, for Alex's parametric equations, how could you define his x parametric? It's just 4, and what about the y parametric? 2t. So that is Alex's parametric equations. X equals 4 and y equals 2t. So, based on these tables, do Alex and Lauren meet on stage? How do you know that they do not? They both go through 4, 6, but Lauren hits 4, 6 at 4 seconds, and Alex hits 4, 6 at 3 seconds. So no, they do not meet because on stage because they pass through the same coordinate at different times. Now, we can always check that we've graphed parametric equations correctly calculator by changing the mode. So last class we were in polar. This class we're in parametrics. So if you go to mode, go down to function, instead of it being on polar POL, you need to make sure it's on PAR or parametric. Oh, you know you're in parametric when you go to y equals and it has both an x equation and a y equation. That's how you know you're dealing with parametric equations. So I just type in, for my Lorentz parametric equations, x equals t and y equals 6. Now to get t, you just press the variable button next to alpha. And then we have x equals 4 and y equals 2t. Right? So we're going to try graphing these first by hand and then checking using our calculator if needed. Now these are actually extremely easy to graph because all we're doing is plugging in values and plotting the points. Now what is important is that you are first looking at your interval for t. You are only graphing for this number 1 from the t values of 0 to the t value of 4. 0 to 4. Sometimes they will like to trick you, like on number 2. What is our interval? -1 to 3, but what does the table tell you to do? So you can't trust the table. You always need to look at the interval it gives you for t. Okay? So let's go back and do number 1. All you have to do is plug in values. We have a time value of 0. So I plug in 0. I plug in 0 for t. What is my x parametric for time 0? 0. What's my y? 3. Then I plug in, instead of 0, the next time 1. What's my x?
3.
What's my y?
3. Sorry.
2. 3 minus 1 is 2.
Oh, yeah, you're right.
Then I plug in 2. What's my x? What's my y? Then I plug in 3. What's my x? And 0. And what's my x for 4? Good. Now this is the only one where the entire parametric does not fit on the graph. We have 0, 3, which is our starting point because that's what the starting value of 0 for time gives us, is 0, 3. Then we have 3, 2. Can I graph 6, 1? No, it's off my graph, but my stopping point for time 4 is 12, -1. So what you do is you connect the dots, just like we do any other graph. Now, like I said, this is the only parametric that you can't graph the full thing. So I will put an arrow to denote that it goes on further. However, parametric equations, one of the most important things is that on your drawn graphs, you denote direction. So because we graphed the starting point and then this next point going to the right, you need to put an arrow that you drew from the left point to the right point. Because this indicates what direction you're going as time increases. So what's important is you look at your intervals and that you're putting arrows. Any questions? I circled it just to show what points I was talking about. Oh gosh.
So that's how you draw it.
You just draw it like this. Now, on numbers 3 and 4, you are using trig, just sine and cosine. I highly recommend that you are trying to do sine and cosine without a calculator and without a unit circle, because on the last day of this unit, we're quizzing over your memory of the unit circle. So try to start remembering, okay, what are the x values at the zero angle? What are your y values at pi over 2? You need to memorize these things. You can draw a little unit circle on your paper. Just don't pull out your actual unit circle. Okay. Okay. Now this next portion is going from parametric to what is called rectangular, which is just our normal y equals x form. Now this is also sometimes called Cartesian form. Cartesian form. This process is called eliminating the parameter, which remember I called the parameter t. T is our parameter. We're getting rid of t. So looking at this example, try not to read the directions. How would we eliminate t? Get rid of t? How do we get rid of t?
We do the I'm sorry, you scared me.
Why?
I don't know. So we'd solve one side of it for t and then input it into the other.
Yeah.
That's like what we did that in like geometry, and what did we call it? Substitute method?
Yes, substitution.
Yeah.
All right. So what we need to do is solve for t in one of these equations and substitute it in to the other. Now the trick is you need your answer to be in standard form. So which equation do you think will solve for t? The x. Because we need it to be in the end y equals. So we're going to solve for x. So we're solving for t in the first equation. How do we do that? Get t alone by doing what first here? We add 1 to both sides, so we have x plus 1 equals 4t. Then we divide by 4. So what does t equal in this problem? X plus 1 over 4. So this is what we substitute in for t in the other equation. We have y equals 6 minus, and instead of writing t, we write yes. Now, the sad news is this in standard form? No. Let me ask this, because I asked third period this, and I was kind of blown away by the responses. What type of line is this?
It would end up being linear, right? Because there's only one x. Oh,
No, but it's divided by 4.
right?
You might be thinking that this is irrational. It is not. Yes. Shh. What creates irrational is a variable in the denominator, which this does not have. This is a what? Linear.
Oh my gosh.
Standard form of a linear
Y equals mx plus b.
is y equals mx plus b. So, there's multiple ways you could get this into standard form. Let me show you what I would do. First, I would distribute this negative in, and in the same step, I would rewrite x over 4 as 1/4 x, and 1 over 4 after the 1/4 x. Ooh, not a plus though. I distribute that negative, and both of these become negative. But then what do I have to do? I have to combine the 6 and the what? Yeah, I need to combine the constants. But right now, can I immediately combine 6 and 1/4? I can? You know what 6 plus 1/4 minus 1/4 is in your head. Just boom. Yes. In your head, what you did was convert 6 into a fraction with a denominator of 4 by multiplying it by 4 times 4 over 4, sorry. So it becomes 24/4 minus 1/4, and what do we get?
23.
So what is our standard form for y equals? Perfect. This is standard form. Do not give me an answer for one of these that has an equation all divided by a single number. That is not standard form. Standard form has coefficients on your variables. Okay? Are there any questions? Yes.
So 1/4 x would that be the same thing as x over 4? Because
But technically that's not standard form. Standard form has coefficients.
Okay.
It is the same thing. It is
that's
the
what
same.
we're doing. We just like moved it around to
Yes,
work for standard.
exactly.